Hello. This video is directed towards Eric Bard specifically, and Brandon Fugel to a degree. Now, yesterday, Eric Bard was asked about my request for data relating to the helicopter drop.
Specifically talking about Mick West on Twitter, where he specifically asked for just the raw data of, I think it was the bottles that you threw out of the helicopter.
And his response was that I need to understand the context and the data and the tools and the entire process. And he went over a little bit of that.
It's logging internally, in this case, a GPS position. I've got some code that I've written to go and parse the resulting files.
He thinks that I need to understand that before I can get to grips with the data. So what I want to do is to basically demonstrate that I do actually kind of understand what's going on there, and I'm quite capable of doing things with that data. So to recap, the bottle drop experiment was carried out on Skinwalker Ranch, and they thought there was an anomaly up in the air above this triangle area of the ranch, and they thought they would drop bottles out of the helicopter to see what happened. Some of the bottles had GPS receivers in them, which would record the GPS data. There were a whole bunch of different bottles. Some of them were dummy bottles, some of them had little cameras in, and 4 of them had these GPS receivers, which were also meant to transmit the data, but that element of the experiment didn't work. Only one of these bottles was actually recovered with workable data. Now, the data from these bottles is stored on a memory card in what is called NMEA format, which is the National Marine Electronics Association. It's a very simple format. It's just a text file with a series of letters and numbers in a kind of a comma-separated value thing, a bit like a spreadsheet. And in this text file, every second there is recorded a bunch of different things, but most interestingly, a GPS position, a latitude, a longitude, and an altitude. So what Eric did with this data was he took it and he converted it into a Blender model. Now, Blender is a 3D program, and it displays things in 3 dimensions, so you can look at them from different angles. So to take the NMEA data and convert it into Blender isn't actually very complicated. In fact, it's a task you could ask ChatGPT-4 to do. You could just do a very simple prompt, and it will spit out the program, and it would work. But even if you didn't have AI to help you, it's not a particularly complicated bit of code to write. It's just taking the numbers from the right positions, converting it from LLA, latitude, longitude, and altitude, to a different coordinate system, probably something like ENU, which is east, north, up, which is a local frame of reference. It's very simple, well understood thing, the type of thing I've done many, many times before. Now, there wasn't just one GPS track being displayed, there was 2. The other one wasn't from a bottle, though, at least not from a bottle that was dropped from the helicopter, because it showed the entire path of the helicopter going up, flying around, and then going back down again. So that track might have actually come from the helicopter's GPS system, perhaps an egg finder in the helicopter, or perhaps something like the ADS-B data from the helicopter. Either way, though, we've got one track which is the helicopter, and another one which shows the bottle going up with the helicopter, then being thrown out, and then descending to the ground. Now, Eric converted the data into this 3D format, and the team looked at it. And in the show, you see they're looking at the data on screen, and they're pointing to the screen, and they claim that there is a bounce. Something bounces, where the bottle actually bounces off something and changes direction in a radical way. This is something that's quite hard to verify just by looking at this thing on the screen, especially for me, from what is being shown. Because it's very hard to look at a 3D perspective projection of something and see what it's actually doing. When you're looking at things from a certain angle, you get perspective foreshortening. Things look very strange when you're looking straight at them versus looking at them from the side. And with perspective, things get even more strange. So what I'd like to do is try to verify the claim that the bottle bounced off something. And there's two ways of analyzing this that I would do. The first one is I would animate the data. Instead of just showing a static model, just showing the path that it takes, I show the actual thing moving along that path. So if there's any bump along that path, you would actually see it. This is far better than simply looking at a line, because you can actually see how fast the object is moving along the line and how much at a time that bump actually takes. Sometimes if it's going around a smooth thing, it's not really bumping. If it goes boom, boom, then you can tell it's actually bumping. The second thing I would do, and this is probably the more useful thing, is that I would graph the second derivative of the position. That's just a complicated way of saying I would create a graph that shows the acceleration or the forces that are acting upon this bottle. Now, the second derivative, what does that mean? Well, the first derivative of something is just how much it changes. So if we have the positions of where the bottle is, we take the first derivative, that tells you the speed or the velocity. If you take the second derivative, that tells you how fast the speed changes, which is the acceleration. Now, a bump in something is actually an acceleration. Its velocity changes either from 0 to something or from something to something else. So if there is a bump, if something is bumping off something, it will show up on a graph of the second derivative. It will show up on a graph of the acceleration as a spike. It'll be very distinctive. So if there is actually something there, something anomalous, then it will show up on this graph. We can do the graph in multiple different ways just to make sure we understand what we're actually looking at. We can do the most straightforward one is the rate of the change of the magnitude of the velocity, which doesn't sound straightforward, but it's basically the speed of the object along its path and how fast that changes. So how fast is it accelerating along the path, the instantaneous acceleration. We can also measure independently the vertical acceleration, which normally would just be gravity minus friction from the air. But if there's something else going on, pushing it up or down, we would see variance in that. We can also separate out entirely the horizontal acceleration. Now, the claim is that there's a bump, which is pushing something to the side. So that would definitely show up as a spike in the graph of the horizontal acceleration. And what's more, we can do both these things. We can animate the scene, we can animate the object moving along the path, and we can show a graph, and we can sync them together so we can show where things are in the graph at any point in this animation, and we can rotate things around in 3D and have a look at it, see exactly what's going on. This is the type of thing that I do. This is the type of thing I've done many, many, many times before. I've got a special tool for doing this, which I call SitRec, Situation Recreation, where I can just drop things in, and I can create scenarios like this with a little bit of extra coding. So I think I will be able to demonstrate very clearly if there is actually some kind of bump or if there isn't. Now, there are concerns that I would manipulate the data, that I would somehow change it. I think the concern was that it was such a small file, it would be very easy for me to change. Well, I'm suggesting that you release the data publicly so that the data cannot be messed with. Other people can very easily replicate what I do. It's not going to be very complicated at all. Anyone can take the second derivative of the position. Very, very simple. Again, you could probably write an AI script to do it for you. If I manipulate the data in any way, it will be perfectly apparent. And I will be completely discredited and game over for Mick. So obviously I'm not going to do that. But you can check. You can check if I do it. So I hope this makes it clear that I understand the situation. I understand where the data came from, what the data are, what you did to the data, and I've explained what I'm going to do to the data to try to verify the claims that were made on the show. So I'll be happy to discuss this more, but if that's enough, you could just email me the data. All I need are the 2 NMEA files, the one for the bottle drop and the one for the helicopter, or whatever format you have that one in if it's not NMEA. And you can email them to me at mick@mickwest.com. Thank you.